Hello and welcome to Codivate's Intro to Block-Based Programming in Scratch. This is lesson 6. Today we're talking about loops. So if you look at this program, the Scratch Cat moves to the center of the screen regardless of where you place it. And today we're going to learn how it's doing that, how it's moving a different amount depending on where you put it to end up at the same place. So the answer to that little question is how the cat's deciding whether or not to move is a conditional. It's either if it's on the left side it moves, if it's not on the left side it doesn't move. But it's moving more than once, so it has to check multiple times. So if you slowed this down, you'd see that the cat is moving multiple times. So after it moves once, it has to check again. Okay, do I need to move a second time? Is it still on the left side? So how is it checking multiple times? Does it just have if statements like 17 times in a row? The answer is no, it has something called a loop. So to understand what a loop is, I'm going to show you a real life example. So if you remember earlier when we were talking about reading and writing code, there was a instruction about washing dishes, and the last instruction read, repeat for each dish in the sink. That is what we would consider to be a loop, because it's telling you to repeat something a number of times, or until something is done. So, for example, for our Scratch Cat, it would be repeating the move to the right until it gets to the middle. So in Scratch, we have two different types of loops. We have a repeat loop and then a RepeatUntil loop. This is a repeat loop, and it's very self-explanatory. It will just repeat whatever's in the middle that many times. So whatever number you put in here, it's going to do it that many times. So you can use loops to do interesting things. For example, this program right here will rotate the cat a small amount, but a lot of times, and it will make the cat look like it's smoothly rotating if you look at this. So instead of rotating 90 degrees each time 4 times, it's rotating just 10 degrees, so a very small amount compared to 90. So it ends up looking smooth like this. A good thing to note here is that this repeat 36 and turn 10, this little block is exactly the same as just dragging over 36 turn 10 degrees blocks. This just makes it look prettier, and it's easier to read. So, with knowing how these work, this repeat 10 means it's just whatever's in the middle 10 times. Try to figure out what this program is going to do. And as we always say, look at the code step by step, trace it. Pretend you're the computer following it. What would you do? So, if you do that, you see, okay, you're gonna, first it's a repeat 10. So whatever's next, you're gonna repeat that 10 times. So it's move 5 steps. Okay, so you're gonna move 5 steps, you're gonna have 10 of those. So it's gonna move 5, move 5, move 5, move 5, 10 times. Then, we're gonna wait a little bit, and then turn around, and then we're gonna move 5, move 5, move 5, move 5 again in the opposite direction. So wherever your cat started, it should end up in the same place, but facing the other way. So if you look, they press the green flag, it moves, turns around, stops. Just like that. Now we're going to do another example the other way around. Instead of looking at code, we're going to look at the output and then figure out what the code is. So here, we have the cat moves, 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 turns around, moves, moves, moves. Okay, so we have 3 moves, a turnaround, and then 3 moves. So if we want to use loops here, those 3 moves can just be a 1 move repeated 3 times. So like this, we have a repeat 3 and it's move and wait. The wait is just there so that you can actually see the cat pause on each step. Otherwise it would look like it's just instantly moving. So the important thing to remember is these 2 programs are exactly the same. They are exactly the same. They do the same thing. They work the same way. One of them is easier to read, and the other one is harder to read. That is really the only difference between these two specific blocks of code, because this repeat 3 with the move and the wait inside is the same thing as just move, wait, move, wait, move, wait. Because it's just move, wait, go back to the start, move, wait, go back to the start, move, wait. That's basically what the loop is doing. Now we have a different type of loop, and it's called a repeat until loop. So what it does is it's like a combination of if statements and repeats. So the way it works is you have just a condition that has to be met in order for the loop to stop. So in our case, we have, in this code, the cat is always moving unless it's on the right side of the screen. Then it doesn't move. So until it's to the right side of the screen, it's going to move. And what we put in here is basically what does right side of the screen mean? Because there's not actually a Boolean that says, is the cat in the right side of the screen? There isn't. What we can do instead is use the X position block, which actually tells us whether or not the cat's on the right side of the screen, because we know from the coordinate plane that if the cat is in the middle, it's at 0, if it's on the left, it's negative, and if it's on the right, it's positive. So we know that we can repeat until the X position is positive, because once the X position is positive, we know it's on the right. So that's really our only condition. So it's going to keep repeating until this condition is true, and it's going to move 5 steps. Now, what's important about this is that we don't know how many times this is going to repeat. We don't. But for the other one, we knew how many times it was going to repeat. We put the number in ourselves. With this one, it repeats until some condition is met. So if you look at each time the green flag is pressed here, the cat moves a different amount each time. So the first time it moves a lot, this time it moves a little bit less, this time it moves less, this time it doesn't even move at all. So it isn't defined how many times this will repeat. It's just we are guaranteed that this is going to be true at the end, this X position greater than 0, because every time the cat stops moving, it's always on the right side of the screen, or at the middle of the screen. So, some exercises. Write a program that moves the cat to the right until it reaches the edge of the screen. And let's just say that the edge of the screen is when the X position is 250. So, it's almost exactly the same as what we just did, except you change this number to 250. So, it's going to keep moving until it gets to 250. I put change X by here instead of move, because we want to make sure that the cat moves to the right, regardless of what direction it's facing. So if it was facing down, we want it to still move right. Next one. Write a program that makes the scratch cat do a smooth front flip. So for this, it's almost the same as that back flip we did. So the trick is, instead of rotating 90 degrees 4 times, you rotate a small number of degrees a lot of times. So this one, it's 300. You repeat 36 times and you turn 10 degrees, and it makes it look smoother. Remember, this is exactly the same as putting 36 turn 10 degrees blocks in a row. And that's why you want to use loops, because dragging it 36 times sounds like a lot of work to me. So this is much easier. You only have to drag 2 blocks. Alright, other way around now. We're going to determine the output from the program. What does this program do? So we're repeating until the Y position is greater than 150. Let's pause for a moment. What does that mean? What does Y position greater than 150 mean? Well, if we draw the coordinate plane, let's say it's a cross, we know that the Y position greater than 150 means that it has to be above a certain line. So there's a certain line that's somewhere above the middle. The scratch cat has to be above that. And if it's not above that, it's going to move it up. And it's going to keep moving up until it becomes above that arbitrary line at 150. So here, you can actually see where that line is by noticing where the scratch cat stops each time. It's clearly like right here somewhere is 150. Next one, write a program that repeatedly asks for a password until the user gets the correct password. Now this one's tricky. This one, yeah, is way more tricky. You have to use the ask block. If you remember how to do that, it's in sensing. There's an ask and then there's an answer. So what you want to do is ask the user for a word, and then check whether or not their answer is equal to whatever password you set. So pause the video, do that. I'm going to show you the answer right now. So basically, you ask what the password is, and this is the key. This boolean right here is the key. Is you're repeating until the answer is equal to, and you put whatever word you want here. I decided to make my password. It's not a very secure password, but this is, you can put whatever word you want here, and it's going to keep repeating until it becomes this word. So what happens is, you ask, what's the password? And you type it in, then it's going to check, okay, is it equal to this magic word we decided? If it's not, the cat will say incorrect, and then it will ask again. Now this asking again changes what our answer is. So the first time it was, let's say 1, 2, 3, and then once it says incorrect, it asks again, so I type ABC. Now when it checks again, this answer is ABC this time. So let me show you on Scratch, because there isn't a GIF for that, I don't think. Yeah. So here, if I make this, ask, what's the password? Let me just make it. Alright, here we go. So, when I click the green flag, the cat asks, what's the password? I'm going to type 1, 2, 3. It says incorrect because 1, 2, 3 is not equal to password. So this is not true. And we're repeating until this is true, so we're going to repeat. So it was said incorrect, now it's asking me what the password is again. If I type ABC, it loops back and it's checking, does ABC equal password? No, it doesn't. So we're going to keep going until it does. It says incorrect again. If I type password, it stops. It goes to the end. And this is because when I typed password, it made answer. So it made the answer password. So now it's saying, does password equal password? It does. So we can stop repeating now, and then it goes to the end. That's basically how that works. Alright. Now, similarly to the last question, we're going to ask the user for a number, and then move the scratch cat left or right by the number given. And negative means left. So, and you're going to repeat that until the user types in 0. So it's very similar to what we just did with the password, except it's a slightly more complicated thing. So pause it, try it. I'm going to show you the answer now. So, very similarly, we have ask, and then we have an ask at the end of the loop. This is generally what the format is. It's initially you ask, and then you ask again at the end of each loop. Just like we have here, you ask and then you ask, but it's this stuff above in the middle that you change. So whatever you want to be the end case, so whenever you want to stop asking them, whatever their answer should be, you put in here. So the answer should be 0 for them to stop. And in our case before, the answer needs to be password for it to stop asking. And whatever we want it to do with our answer, we can say. So we change x by answer. This might be a little new to you, but you can put bubbles in anything that has a bubble. So when you change x by answer, if you type in 2, it's going to move the cat 2 when you run this block. If you type in 0, it's going to realize that this boolean right here returns true, and it's going to not repeat at all. It's just going to skip it. Let me show you real quick. Alright, here. So, when I click the green flag, it says, how far to move. I type 90, and it moves the cat really far to the right. Now if I type negative 100, it'll move the cat really far to the left. If I type 0, it'll stop. The same way the password was, just like the password, except when you type in the quote-unquote incorrect answer, instead of saying incorrect and asking for another one, it moves the cat and asks for another one. That's really the only difference. And that is all for this lesson. Thank you for watching.